Good morning. This is your Stats Sensei, Mr. Sensei, and this is an exit ticket for chi-squared. All right, this is a scenario college stats that we've been using today. To investigate whether taking high school statistics impacts college GPAs, a very large school district randomly selects 450 former students out of the more than 20,000. So this right here, random sample of 450. They also classify each student's college performance based on their GPA into three categories. Determine whether there's a statistical evidence that taking high school stats is associated with college performance. Answer the following in space below. How many samples? One. All right. How many? List the variables and the levels. Well, there are two variables, and the variables are took stats, which is two levels, yes or no, because it was two levels. You could either be yes, you took it, or no, you did not. Yes or no. And the other variable is GPA, and there are three levels: high, medium, and low. And I'm just going to put H, M, and low. All right. So one sample, two variables. You took stats, yes or no. And the GPA was the other variable, and it was high, medium, low. So you have two levels here and three levels there. The next part of the exit. A college student organization is conducting a study to determine whether students at their university have an equal preference for different types of pets. A random sample of 450. And by the way, I know that's what they're going to ask me about. A random sample of 500 students from a population of at least 6,000 is surveyed, and each student is asked what type of pet they own. All right, when I look at this, it says how many samples are there? Well, there's one. There's one sample, and there's only one variable, and the variable is the pet type. That pet type has five levels. It could be a dog, it could be a cat, it could be a fish, it could be a reptile, it could be no pet at all. All right. And then it says which pet type contributed the most to the chi-squared statistic. Justify your response. To do that, I need to run that test again. So stat test, chi-squared goodness of fit. There's all my information, my degrees of freedom, 5 minus 1. And I have a contribution of 4, 16, 4, 1, and 9. I see that 16 is the second one, and that's the biggest. Well, that means cats had the largest. All right, let's go back and look at this real quickly. I had expected values of 100. And it says, justify your response and show the calculation. Well, cats contributed the most with the chi-square of 16. We pulled that off the calculator. But what about the computation? Well, the computation would be 140 minus 100 divided by 100, because this is my observed, this is my expected, and this is my expected. So let's try that out. Parenthesis 140 minus 100, close, squared, divided by 100. And sure enough, it equals 16. And that was the CNTRB, the largest contribution. The other thing I want to point to while I'm here, since this is an easy one, stat test, chi-squared goodness of fit. When we run this, we actually get a chi-squared value of 34. Well, let's add up 4 plus 16 plus 4 plus 1 plus 9. Stat test, and let's add them up. 4 plus 16 plus 4 plus 1 plus 9. That equals 34. Because remember, the contributions sum up to the actual chi-square value. All right. And this was dogs had a 4, cats had a 16, fish had a 4, reptiles had a 1, and no pets had a 9. All right. All righty. I appreciate you watching. Look forward to seeing you on the next one. Study for your test and let's do it well. All right. Thank you.